All right, ready to dive deep? Today it's all about uh, chemistry's green guardians.
No, I like that.
Yeah,
Yeah.
you sent us this fascinating episode of Cocktail Party Chemistry,
Yeah.
all about advanced corrosion protection and environmental solutions.
Yeah.
And I got to say, I'm pretty excited to dig into this.
Yeah, it's really cool. We often think of chemistry as, creating problems.
Right.
But in this case, it's really stepping up to solve some major environmental challenges.
Yeah, it's like the good side of chemistry.
Absolutely.
So we're exploring 5 key areas today, and each one is kind of like a superhero in its own right.
Okay.
We've got biomimetic mineral coatings,
Okay.
graphene oxide, nanoporous materials, catalytic water splitting,
Wow.
and superhydrophobic coatings.
That's a mouthful.
It is, it is.
But they're all really fascinating. And what's interesting is that a lot of these solutions are actually inspired by nature itself.
Oh, interesting.
So scientists are taking cues from the natural world to develop these innovative and sustainable technologies.
So it's like we're looking to nature for the answers.
Exactly. Yeah.
Okay, well, let's start with these biomimetic mineral coatings.
Okay.
What comes to mind when you hear that?
Well, I think about nature and how nature has already solved a lot of the problems that we're facing.
Right.
And so, if you think about a seashell,
Okay.
it's constantly exposed to salt water, which is incredibly corrosive,
Right.
but it remains intact for years and years.
And it has that beautiful pearlescent coating.
Exactly.
It's like armor.
It is. It's natural armor, and scientists are studying the structure of these natural coatings and trying to replicate them
Oh, wow.
to create these protective barriers for metals.
So instead of using like harsh chemical treatments or something like that, we can actually
Right.
mimic nature's designs
Exactly.
to prevent rust and corrosion.
Precisely.
That's pretty cool.
Yeah. And these coatings can extend the lifespan of bridges, pipelines, vehicles,
Ugh.
you name it, anything that's metal.
So it's not just like small things, it's large scale.
It's everything, yeah. And that translates to fewer resources needed for repairs and replacements,
Right.
which is obviously a huge win for the environment.
Yeah. And probably saves a lot of money in the long run, too.
Absolutely.
So less waste, fewer emissions, and a longer lifespan for our infrastructure.
Yeah,
That's impressive.
it is. It is. And it highlights a key theme that we'll see throughout this whole deep dive.
Okay.
Nature often holds the answers to the challenges that we're facing.
I love that.
Yeah.
Okay, so we're going from seashells to something even tinier now, graphene oxide.
Okay.
Now we're talking about purifying water at the nanoscale.
Right.
I have to admit, nanotechnology always sounds a little bit like science fiction to me.
It does. It has that futuristic feel,
It does.
but it's very real
Yeah.
and it's incredibly powerful.
Yeah.
So graphene oxide is essentially a single layer of carbon atoms
Okay.
arranged in this honeycomb pattern.
So we're talking like a sheet of atoms. That's how thin we're talking.
Yeah, one atom thick.
And this can purify water.
It can, yeah, because it's so thin and it has very specific chemical properties.
Right.
It can be used to create filters with incredibly tiny pores,
Right.
so small that they can actually trap even the tiniest impurities like heavy metals, bacteria, viruses,
Wow.
things like that.
So we're talking about filters that could potentially provide clean drinking water to, communities
Exactly.
that lack access to safe water sources.
Exactly. Yeah. Imagine a portable filter that you could take anywhere and it could remove virtually any contaminant from water, making it safe to drink.
Wow.
That's the potential here.
That's mind-blowing.
Yeah.
Okay, shifting gears now to something that feels incredibly relevant given the state of our planet. Nanoporous materials for CO2 capture.
Yes.
This feels like a really crucial weapon in the fight against climate change.
It's a hot topic, and for good reason. Nanoporous materials are essentially sponges, but at the molecular level.
Good.
They have these tiny, precisely engineered pores that can trap specific molecules,
Okay.
and in this case, CO2.
So it's like a microscopic net that only catches carbon dioxide molecules.
That's a good way to think about it.
Okay.
Yeah, so these materials could be used in power plants, for example, to capture the CO2 emissions from flue gas before they're released into the atmosphere.
So like adding a filter to the smokestack.
Right, exactly.
I've also heard about the possibility of using these materials to pull CO2 directly from the air.
Yes.
Is that something that's being explored?
Absolutely. Direct air capture is a very active area of research.
Wow.
And the idea is to develop materials that can efficiently capture CO2 from the atmosphere, even at low concentrations.
That sounds like a game changer.
It has the potential to be a really important tool.
Yeah, if we could effectively remove CO2 from the air, That could be a huge step towards mitigating climate change.
Absolutely.
And then what do we do with it once we capture it?
Well, that's a great question.
Besides store it underground.
Besides storing it underground, which is a good option, there's this growing field called carbon utilization, where the captured CO2 is actually used as a feedstock to create valuable products.
Like what, are we turning it into diamonds?
Maybe not diamonds yet.
Okay.
But scientists are exploring ways to use CO2 to create everything from fuels and plastics to building materials.
So instead of treating CO2 as waste, we can actually turn it into a resource.
Exactly. It's a really great example of circular economy thinking.
I love this. Okay, on to number 4 on our list of chemistry superheroes, catalytic water splitting.
Oh, okay.
This one sounds like it has the potential to revolutionize the way we think about energy.
It does. It's a really powerful idea.
Yeah.
So catalytic water splitting is the process of using catalysts to break down water molecules into their components, hydrogen and oxygen.
And hydrogen is where the clean energy part comes in.
Exactly.
I remember learning in school that hydrogen is a highly flammable gas.
It is, but when hydrogen burns, the only byproduct is water.
Right.
So it's a completely clean fuel.
So if we can efficiently produce hydrogen from water,
Yeah.
we'd have a virtually limitless source of clean energy.
Exactly.
Okay, I'm already picturing a future where our cars run on water.
Right.
But I'm guessing it's not that simple.
Not quite that simple. There are definitely some challenges.
Okay.
One of the biggest hurdles is finding efficient and cost-effective ways to split the water.
Okay.
The process requires energy, and we need to make sure that we're getting more energy out of the hydrogen than we're putting in.
So it's a balancing act.
It is, yeah.
We need to make sure the process itself is energy efficient.
Exactly. And that's where the development of better catalysts comes in.
Okay.
Researchers are working on catalysts that can split water using renewable energy sources like solar power.
So imagine a system where we're using sunlight to split water and create hydrogen fuel.
Right.
It's like harnessing the power of the sun to create clean energy.
Yeah, it's a compelling vision.
It is.
And as the technology continues to improve, we're getting closer to making that vision a reality.
This is all so fascinating. Okay, last but not least, we have superhydrophobic coatings.
Okay.
Now this one sounds like it's straight out of a sci-fi movie. Surfaces that repel water like magic.
It's pretty amazing.
Yeah.
Yeah, think about a lotus leaf.
Okay.
Water beads up on its surface and just rolls right off, carrying away any dirt or debris.
Right.
That's the effect that scientists are trying to replicate with these superhydrophobic coatings.
So it's like having a self-cleaning surface.
It is.
Sign me up.
Yeah.
But beyond just keeping things clean, are there other applications for these coatings?
Oh, absolutely.
Okay.
Think about airplanes. Ice buildup on the wings can be a serious safety hazard.
Right.
But if you have a superhydrophobic coating, water simply rolls off before it has a chance to freeze.
Ah, so it's about preventing ice formation, not just keeping things clean.
Right.
That's incredibly useful. Are there any other interesting applications?
Well, in the medical field, researchers are exploring superhydrophobic coatings for implants and medical devices. The idea is that these coatings can prevent bacteria from attaching to the surfaces,
Interesting.
which could reduce the risk of infection.
That's huge. That could have a major impact on healthcare and the fight against, antibiotic resistance.
Absolutely.
Wow, this is all so incredibly promising. We've covered so much ground already, from rust prevention to clean water to clean energy and self-cleaning surfaces.
It's really a testament to the ingenuity of scientists and their ability to find creative solutions to these environmental challenges.
It is. And the exciting part is we're just scratching the surface of what's possible.
Absolutely.
Okay, we're going to take a quick pause here, but don't go anywhere.
Okay.
We'll be right back to delve even deeper into these fascinating solutions and explore what they mean for the future.
Welcome back.
As we were talking, I was thinking about how each of these innovations is like a piece of a larger puzzle.
Right.
A puzzle that, when solved, leads to a more sustainable future.
It's a great way to put it. It's not just about finding, isolated solutions. It's about creating a more sustainable system as a whole.
Absolutely. So let's revisit those biomimetic mineral coatings.
Okay.
We talked about their potential, but I'd love to hear about some real-world examples of how they're being used.
Yeah, so one exciting application is in protecting bridges and other infrastructure from corrosion. Think about the Golden Gate Bridge.
Oh, yeah.
Constantly exposed to that harsh, salty air.
Right.
These coatings can significantly extend the lifespan of structures like that,
Wow.
reducing the need for those costly and resource-intensive repairs.
Right. It's not just about the environmental impact. It's about the economic benefits, too.
Absolutely.
Less maintenance, fewer materials needed for repairs. It all adds up.
Exactly. And it's not just about big infrastructure projects either.
Okay.
Think about cars, ships, even household appliances.
Right.
Anything metal that's exposed to the elements could benefit from this kind of protection.
So longer-lasting cars, less rust on our bikes.
Exactly.
It's making me think about all the things in my own life that could benefit from this.
And don't forget, these coatings can also improve performance.
Oh, really?
For example, they can reduce friction,
Interesting.
which could improve fuel efficiency in vehicles.
Okay, so less wear and tear, better fuel economy. It seems like a win-win all around.
It is.
Now let's jump back down to the nanoscale and talk more about those graphene oxide filters. It's hard to wrap my head around something so small having such a huge impact.
It is remarkable, isn't it? What's truly impressive is that these filters can remove such a wide range of contaminants. We're talking heavy metals, bacteria, viruses,
Wow.
even things like pesticides and pharmaceuticals.
I remember reading about how these filters could be particularly impactful in developing countries,
Yes.
where access to clean water is often limited.
Absolutely. These filters could be used to create portable water purification systems,
Right.
making clean drinking water accessible, in remote areas or disaster zones,
Yeah.
places where traditional water treatment infrastructure is unavailable or has been damaged.
It's almost like having a superpower, the power to create clean water wherever you need it.
It's a technology with the potential to save lives and improve global health.
Okay, shifting gears now to CO2 capture with nanoporous materials.
Yeah,
This one feels incredibly urgent given the climate crisis we're facing.
right.
Are these materials already being used to capture carbon?
They are, yes. One promising application is in power plants. So nanoporous materials can be integrated into flue gas systems
Okay.
to capture CO2 emissions before they're released into the atmosphere.
So it's like adding a filter to the smokestack.
That's a good way to think about it.
Okay.
And the captured CO2 can then be either stored safely underground
Right.
or even more excitingly used to create valuable products.
We touched on this earlier, but I'm really curious to hear more about what kinds of products can be made from captured CO2.
Well, there's a lot of research focused on using CO2 as a raw material for things like plastics, building materials, even fuels.
Really?
Imagine a world where we're not just reducing emissions, but actually using that captured carbon to create the things we need.
It's amazing. It completely changes the way we think about carbon emissions. It's not just waste, it's a potential resource.
Exactly.
Okay, on to a topic that always gets me excited. Catalytic water splitting. This idea of unlocking a truly clean energy source from water is just incredible.
That is.
But I know it's not quite as simple as it sounds. What are some of the challenges in making this a viable energy source?
You're right, it's not without its challenges. One of the main hurdles is efficiency. The process of splitting water requires energy.
Right.
And we need to ensure that we're getting more energy out of the hydrogen than we're putting in to split the water in the first place.
So the balancing act. We need to make sure the process itself is energy efficient.
Exactly. And that's where the development of better catalysts comes in.
Okay.
Researchers are working on catalysts that can split water using renewable energy sources like solar power.
So imagine a system where we're using sunlight to split water and create hydrogen fuel. It's like harnessing the power of the sun to create clean energy.
It's a compelling vision. And as the technology continues to improve, we're getting closer to making that vision a reality.
I can't wait to see where this technology goes in the future. Okay, last but not least, let's dive back into the world of superhydrophobic coatings.
Okay.
Those self-cleaning surfaces are still on my mind,
Yeah.
but I'm also curious about how these coatings might be applied in industries beyond just keeping things clean.
Well, one area where they're showing a lot of promise is in preventing corrosion. You see, water is a major factor in rust formation.
Right.
So by repelling water, these coatings can act as a barrier against the elements and prevent corrosion on metal surfaces.
So it's like an invisible shield against rust.
Exactly. And think about the applications. Bridges, ships, pipelines,
Wow.
anything metal that's exposed to the elements could benefit from this protection.
And we talked about airplanes earlier, how these coatings can prevent ice buildup on the wings.
Right.
It seems like the applications are endless.
They are. And there's even research being done on using these coatings in the medical field. Imagine implants or medical devices that are coated with a superhydrophobic material.
You mean like a coating that could prevent bacteria from sticking to the surface?
That's the idea. It could potentially reduce the risk of infection and improve the safety of medical implants.
Wow, that's incredible. So we've
Wow.
got rust prevention, anti-icing, antibacterial properties. It seems like these coatings can do it all.
It's a truly remarkable technology,
Yeah.
and like many of the solutions we've discussed today, it highlights the power of biomimicry,
Right.
taking inspiration from nature to solve human problems.
As we've been talking about these 5 areas, I've been struck by how interconnected they are.
Yeah,
It's not just about isolated solutions, it's about creating a more sustainable system.
that's a key takeaway from this deep dive. These innovations are all pieces of a larger puzzle.
Right.
A puzzle that, when solved, can lead to a healthier planet and a brighter future for all of us.
Well said. And that's a perfect note to end on as we take a short break.
Yeah.
But we'll be right back to wrap things up and explore what these exciting innovations mean for the future. Stay with us. And we are back for our final look at chemistry's green guardians. And I am feeling pretty optimistic about the future.
Yeah, me too. It's inspiring to see how scientists are using chemistry to address some of our biggest environmental challenges.
Yeah, it really is. So as we wrap up, I'd love to get your take on the bigger picture. Where do you see these innovations leading us in the years to come?
Well, I think we're at a pivotal moment. For a long time, these technologies were mostly confined to labs and research papers.
Right.
But now we're seeing them move into the real world, becoming more practical and scalable.
So you're saying we're moving from theory to application,
Exactly.
from lab experiments to actual solutions that can make a tangible difference.
Yeah, and as these technologies become more widespread, I think we'll start to see this ripple effect.
Oh, interesting.
Imagine a world where bridges and pipelines last for centuries, where clean water is readily available even in remote communities, where we're using carbon dioxide as a building block for new materials.
It paints a pretty incredible picture.
Yeah.
It's like we're on the cusp of a more sustainable era where chemistry is playing a leading role in protecting our planet.
I believe so, and it's important to remember that we've only just scratched the surface.
Right.
There are countless other innovations happening in the field of chemistry that are focused on sustainability.
So this is really just the beginning of a much larger movement towards a greener, more sustainable future.
Absolutely. And what's particularly exciting is that this movement is driven by a growing awareness that we need to find ways to live in harmony with our planet. It's not just about fixing problems, it's about creating a better future for generations to come.
That's a powerful thought. It's not just about mitigating damage, it's about proactively creating a more sustainable and equitable world. And speaking of creating a better future, we've talked a lot about how scientists are drawing inspiration from nature to develop these solutions. But what if we took that a step further?
What do you have in mind?
Well, what if instead of just mimicking nature, we found ways to actually collaborate with it, to integrate these technologies into ecosystems in a way that not only minimizes harm, but actually enhances natural processes?
That's a fascinating idea. It's like moving beyond sustainability to a point where we're actively regenerating the environment. Instead of just reducing our footprint, we're finding ways to make a positive impact.
Exactly. I think there's so much potential in that approach. Nature's been solving problems for billions of years, and we have a lot to learn from her wisdom.
I couldn't agree more. It's a reminder that we're part of nature, not separate from it. And the more we can align our innovations with natural systems, the more sustainable and harmonious our future will be.
Well said. And on that hopeful note, we've reached the end of our deep dive into chemistry's green guardians. But I hope this is just the beginning of a much larger conversation for all of us.
Yes, the exploration doesn't end here. We encourage you to keep learning, keep asking questions, and keep seeking out solutions.
Because the more we understand about the challenges we face and the innovative solutions being developed, the better equipped we'll be to create a future where both humanity and nature can thrive. Thanks for joining us on this incredible journey.